Now let's look at this system of equations. This one is a bit different from the one we had earlier in example 1, where you can add up the two equations, then one variable will be gone. If I want to get rid of the y here, somehow I have to make the y in the first equation 2y. So that's what I'm going to do. I'm going to multiply the first equation by 2. So that means every term in the first equation will be multiplied by 2. So I have 6x plus 2y equals negative 22. I'll call this new equation equation 3. Okay, if I add up the new equation 3 with the equation 2, the y term will be gone. So adding up the two equations, 6x plus 6x is 12x, negative 2y plus positive 2y is 0 equals negative 2 plus negative 22 is negative 24. Now solve for x. Divide both sides by 12. X equals negative 2. Okay, now solve for y. You can plug in x equals negative 2 in either equation 1 or equation 2. I'm going to plug it into the original equation 1. That will give me 3 times x is negative 2 plus y equals negative 11. So negative 6 plus y is negative 11. Add 6 on both sides. You will have y equals negative 5. So the solution to the system is x equals negative 2, y equals negative 5. Or you can say the solution is negative 2, negative 5. So what we did here was somehow get rid of the y variable first. Is it possible that we get rid of the x variable first? It actually is. If you want to get rid of the x variable, the x first, what you can do is turn this 3x to negative 6x so that the two equations add up. The x terms will be gone, right? So I'm going to call the first equation equation 1, second equation equation 2, and turn 3 into negative 6. I need to multiply it by negative 2. So I will do equation 1 times negative 2. So every term will be multiplied by negative 2. So first term, that's negative 6x. Negative 2 times y is negative 2y equals negative 2 times negative 11 is positive 22. Call this equation 3. All right, let me add up equation 2 and equation 3 so that the x terms will be gone. So 6x plus negative 6x, the x terms are gone. Negative 2y plus negative 2y, that will give you negative 4y equals negative 2 plus 22, that's 20. Divide both sides by negative 4. You get y equals negative 5. It's the same answer as the first method, right? Now, to solve for y, you can plug it into either equation 1 or equation 2. So let's do equation 2 this time, because last time we did equation 1. So 6x minus 2 times negative 5 equals negative 2. So you have 6x plus 10 equals negative 2. Subtract both sides by 10. 6x equals negative 12. Divide both sides by 6. You will have x equals negative 2. So you'll get the same solution. X is negative 2, y is negative 5. Okay, now I want you to work on B by yourself. So pause the video, and when you're done, You can click play and check your answer. Okay, so for this problem, it seems like it's easier to get rid of the x terms because I can just make this x -3 so that -3x plus 3x will be canceled out, will be 0. Right, so I need to multiply the first equation by -3. Equation 1 times -3, that will give me -3x, -3 times 5y, -15y, equals -3 times 18, that's -54. I'll call this equation 3. Okay, now if I add up the equation 2 and this new equation 3, then the x terms will be gone. So 2y plus -15y, that's -13y, equals these two, -11 plus -54, that's -65. Okay, divide both sides by -13 to leave y by itself. Y equals +5. All right, now solve for x. You can plug in y equals 5 into equation 1 or equation 2. I will choose equation 1 because the numbers are generally smaller. Okay, so x plus 5 times 5 equals 18, and then x plus 25 equals 18. Subtract 25 on both sides. I'll get x equals -7. Okay, so the solution is x equals -7, y equals 5. So for this problem, it's easier to get rid of the x terms instead of the y terms because you can just multiply the first equation by -3, right? To get rid of the y terms, you can't just multiply one equation by one whole number. Maybe you can multiply everything by -2.5 to get this -5, but we don't want to deal with decimals, right? So we will get rid of x first instead of y for this problem.